I think for today, there's only 3 examples that I have, but it's not, like I said, really different from what we went through yesterday. It's just more practice, and maybe there's a little bit more you have to do in order to do step 1 to separate the variables. But I want to give you chances to work through that as well. So what I actually think I'm going to do is, for example 1, and I'll be walking around to help out as well. I'd like you to try solving example 1. So remember those 3 main steps. First, you have to separate your variables. In this case, z is your dependent variable since your derivative is dz dt. Z is a function of t in this problem. So separate your variables in step 1. Once that is done, integrate both sides. Here we do not have an initial condition, so then you would solve for z if possible for that 3rd step. So I want you to try example 1, and then
this is the same as an xy though?
We'll check. Yes. So this would be the same if
dx over dy?
Yes. It's just you have z and t. So if it really matters to you, you could change it to x and y if that helps you work through it. But make sure your answer is in terms of the variables they give you.
Why can't you have 2 of them? Or like ever? It seems like you never hear that.
Well, he has so many shoppers. Dude.
That's what I got.
Wait, no,
we got yeah.
Oh, yeah. I know. Why? How'd you get rid of that? Oh wait, I got it.
Hey,
Kind of sit in the bucket. Oh. Oh no, you didn't. Oh, nothing changed. I know. No, that's right. Get it right.
No, I know.
Oh, dude, they're doing this big thing on Nature Report about athletes who smoke weed, like all the vitamins and stuff. Oh, oh, I solved it. I solved it. What is? Solved it. I solved it.
Oh, that's right.
Alright.
Natural log yeah. What kind of natural log?
What'd you get? What'd you get?
Ooh, we're close to each other.
But then I think Alan, yeah, it's equals one. You have the same answer, dude. Oh! Tyler, what are you doing tonight?
What am I doing? I practice working till 7. Hanging out with the boy. Is it Friday today?
Yeah, it's right. Rick and Ty are available tonight. That's where Austin and I are. You might have to run it. I'll ask my mom. What do you think, Mr. Gazelle, right? Oh, we're wrong,
Yeah,
Connor.
but we're running together.
Okay, I'm not going to show the full answer. I just want to show at least the first step. So separation of variables, you should have 1 over e to the z dz, or if you have dz over e to the z, and then negative e to the t dt. Now this negative could be on the other side as well. It doesn't matter which side the negative is on. But that would be the separation of variables part, and then you integrate both sides. Now some of you might be stuck at this point or may have moved forward from this point incorrectly. You cannot take the antiderivative of 1 over e to the z written this way. So it is not natural log of e to the z. You can't even use substitution the way this is written because your u would have to be e to the z, but the derivative of that is e to the z, and there isn't a second e to the z in the integral. You can rewrite this, though, as e to the negative z, and then use substitution, yes. Okay, so if you were stuck at that point, or maybe you moved forward to find an antiderivative, but you didn't rewrite it this way, make sure you do that. Now, I also want to show this. I'm going to show this, and then along with it, kind of show a shortcut. So anytime you have a function e to a power where it's more than just a variable, like there's some coefficient in front of that variable, in this case it's -1, really you are using substitution. you're saying, in this case, u would equal negative z, and therefore du would equal, the derivative here would just be negative 1, and then dz, but we only have a dz, we don't have the negative 1, so we'd have to divide both sides by the negative 1, which ends up just making this side negative 1 du. So if you were to rewrite this integral, it would be, the negative 1 would be in front, and then you'd have the integral of e to the u du. This side, you don't need substitution to integrate. That's just straightforward. But what happens here then is the antiderivative of e to the u is e to the u, and you have this negative in front. If I substitute the u back in, it's just negative e to the negative z. So what I want to show you as a shortcut, because you wouldn't necessarily need to use substitution every time, when you have a coefficient in front of that variable, like say I had e to the 3z instead of the negative z, that means by substitution, this here, I'm going to write over this so it now applies to here. This would be a 3, meaning this would be a 3, meaning this would be a 1/3. So in general, when you're taking the antiderivative of something like this would be 1/3 e to the 3z. You get a coefficient of the reciprocal of whatever this is. And it is by substitution, but if it's in that form, that way you wouldn't have to do the substitution every single time. Trying to be helpful. If that totally just confused you, do the substitution every time. But move forward from there. I want to give you a chance. If you already got to this point, so you'd have negative e to the negative z equals the antiderivative of this side. If you got to that point, awesome. But if you didn't get to that point, go ahead, find what you think your answer is, and then we'll check the answer. If you're ready to go, you can move on to the next one and start that. But I want to give everybody a chance to answer this one correctly first.
What am I doing wrong? Then do it.
So this negative is that's just the root of it. So that is the solution, but if you're able to find this, able to solve it. You have to solve that. You don't know how you want to.
Oh.
Well, getting rid of this negative.
Oh.
So this actually doesn't, this one will cancel out, we'll just have negative z. This side though, you can't cancel it because you have actually minus z.
I think I'm that's what. Whew. So I can fly. I feel like this hour's been long. I got practice. What the? How much did you have? We have 8 gigabytes for 4 people. Yeah, no shit. What? That's the only thing I do. No, it's all right. Dude, everyone's like, you're like, yo, no.
And then like a little bit later, all right, there you go.
I can take 4 just take like 4 more. And then I'm like, literally 15 minutes, you're like, like sitting on the couch, like, okay, your tongue off, like, and then like you sober up like later to go again.
I'm gonna show
Connor, I'll talk to you.
negative here still out.
Hey, I'm close in on high.
Okay,
I'm close in on high.
here we go. Everybody check what you have. I'm seeing some very different answers walking around. That's okay. Fix your mistakes if you made any. So I already explained how to get your antiderivative of the side with z. Make sure when you integrate both sides, in this case it's the side with t, otherwise it would be your side with x. Make sure you include the plus c. You cannot just add that on to your answer at the end because it affects your solving for your z in this case. So you need the plus c. Then you have to solve for z if you're able to, which we can in this case. So you would divide each side by a -1. Now I put minus c. If you still had plus c in your answer, that's technically okay because a constant divided by a negative, it's still a constant. But what I'm going to show or explain an example to, and I know some of you are already starting to work through that, is when you're ever trying to find your value of c, if we were given an initial condition for this problem, you'd want to find c here before you solve for z. So I'll explain that in example 2, but I'm just saying here if you had plus c, that's really okay. And then from here, when you take the natural log of both sides, this is important, you are taking the natural log of the entire right side. You cannot distribute natural log. So this e here does not cancel out. The one over here does. It does not for the e to the t. So you still have natural log of e to the t minus c, or plus c is fine. You have a negative z. Divide each side by -1, so your final answer should be negative natural log of e to the t minus c. Or plus c is fine. Okay, now realize how much goes into one of these problems. And these types of problems, if there's a problem on the AP test that will ask you to solve a differential equation, I've seen this type of question worth 5 or 6 points alone. Every free response question in total is worth 9 points, and I've seen just this worth 6. So there's a lot that goes into these. You have to be very careful, and it's a lot more than just knowing how to find an integral. There's a lot of review of pre-calc and algebra to solve for a variable. So I know I stress practice a lot, but I can't stress practice enough for these with little things that come up. Are there any questions on this one problem right now? Yes.
So how come the antiderivative put e to the, well, there's, we have e to the negative 1.
Yep.
What is this antiderivative? E to the negative 1 is
Yep.
explain why those derivatives are not like the
I showed that entire thing already in detail with substitution. Oh, okay. I mean, I can explain that too, but I explain that to the whole. It's because of substitution. You would let your u be negative z, and that's why it ends up having the negative in front, whereas this negative is just a coefficient, and the antiderivative of e to the t is just e to the t. But because this negative is here that makes this antiderivative different. I can show you that if you missed it though. Okay. Okay, any other questions on example 1 before we move on? Okay, example 2. And if you started this one, I would just make sure as we go through it that you got to the right answer. I will say for this one, so if we are solving this, and again, if you are asked to solve these, it's not a trick. I'm not going to give you one that isn't possible to separate and not possible to solve. They don't on the AP test either. They're not going to trick you. But how would you separate your variables on the right side here? Yeah, so we have dy dx equals, we have y over 1 plus y squared times cosine of x. We could write it that way. So a function of y times a function of x. This y of 0 equals 1, that's the initial condition, so we'll be able to find C for this one. So C should not be left in our answer. And I'm going to show you again where I recommend you find C. I do not recommend you find C at the very end of the problem. So here we need to multiply both sides by the reciprocal of our y function. So I will have 1 plus y squared over y dy equals cosine of x dx. Of the y's. So integrate both sides. How do we integrate 1 plus y squared over y? You could, but because then you have a product, it doesn't work to just take the antiderivative of each, like of a product, and have a product in your answer. So splitting it that way, wouldn't help necessarily, Liz. Yes. So because you can split a fraction, or you can split a numerator, I should say. So this would be 1 over y plus y squared over y, and that would simplify to just y. So this is really the integral of the quantity 1 over y plus y. Which then that is helpful because both 1 over y and y have antiderivatives. So substitution is not needed. So what would the antiderivative of 1 over y be? Natural log of absolute value of y. And then antiderivative of y, 1/2 y squared equals antiderivative of cosine of x, sine of x, and then don't forget your plus c here. So, well, you're finding indefinite integrals, so they technically both have a plus c, but if you have a constant on both sides and then you subtract to one side, it's still a constant. So you only need it on one side. I recommend the side with x. So here, this is the point where if you are given an initial condition, you should plug that in to find your C. So this is the point you should automatically find C before you try solving for y, if you can. So I'm going to substitute in the 0 for x and the 1 for y to find C. So we would get natural log of the absolute value of 1 plus 1/2 times 1 squared equals sine of 0 plus c. What's the natural log of 1? 0. 1/2 times 1 squared is just going to be 1/2. Sine of 0 is 0. So c is just 1/2. So then substitute that back in. So natural log of the absolute value of y plus 1/2 y squared equals sine of x plus 1/2. And now, if you can, solve for y. So I'll put solve for y if possible. So just note that step. So once you have integrated both sides, if you are given a condition to find c, find it there before you try solving for y. And then, can we solve this for y? No, because you wouldn't be able to factor out a y from a natural log. So this is actually your answer. No. You saw your truck. No. Yeah. 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 I know. Hardcore. Okay, the last example, example 3. Jazz people, bye. Have fun. Have a good weekend. This one, I would like you to try. So try working through example 3. Yes.
Oh, dang it. Caught myself.
Did you though? You already said it.
Is that still recording?
No. Well, you have more in the square root than just the square root, if that makes sense. Like here.
Get it.
Oh, hey, brother, I was and I just
Wow, you guys are really driving. No, that's good. That's good because I mean, when you're a sailor, you have to know how to.
Why did I?
what the hell? How did you get a C equals 2? Oh my god.
Y squared. Y is 1. Got 1 on the side. Now you're going to end the Y.
Good enough, right? Send it. Awesome to throw. Fuck no. What was your answer? Are you right? Oh my god.
Okay, I'm gonna show.
I would never do it.
I'm gonna show this. Check what you have. I also have something to explain with this. That's important. I realize some of you may not be completely finished. I think in terms of what I've checked, everybody got the separation of variables okay. You do have to use substitution to find your integral with x. What I want to explain at the end, I'll show the answer. If you're not getting to this and you have questions and you're not able to get to this, please let me know. So your answer is y equals the positive square root of 2 minus the square root of x squared plus 1. So here's what I have to say about this though. When you take the square root of both sides, you technically get plus or minus the square root. I just put the 2 in front here. If you didn't have that in front, that's okay. Of the minus x squared plus 1 square root. But technically, when you take the square root of y, you get plus or minus. The reason the positive square root is your answer is because in your initial condition, when x is 0, y is positive 1. So if this would have been negative 1, you would have to make your square root negative in your answer. So it's when you take the square root or the fourth root or the sixth root of something, you have to look back. If you're given an initial condition, whatever the sign of that is the sign you should be including in your answer. Because if I plug in 0, I'm going to get the square root of 1. And if I need it to be positive 1, that's why it's positive. If it was negative, I'd have to put a negative in front. If I didn't have an initial condition, I would have to have plus or minus in my answer. So if we were not able to find C, you would have to have plus or minus in front of that square root. Why is it plus or minus? What's your question?
You said